All right, so in this episode, you are looking at 9618443, variant 43, that is, of October, November 2023, and we will be doing the Java implementation for the last question, which is question number 3. All right, so let's go to where the question is. All right, so this one is an OOP question, as it happens. All right, so the game is multiple characters that can move around the screen, right? A game is being developed using OOP, and the game is multiple characters that can move around the screen. We have this character class going on. We're given a class diagram right here, and of course, by now you should know that the first section, that's the variables or the fields as it were, and then the second section are the methods or the functions as it were. And of course, we have the description of what it does, each variable, and what each function does. Then we are to write program code to declare the class code character and its constructor, and we are not to declare any other methods. So we're just focusing on the class character, the character class. Wait, is it the character class? Yeah, the character class, as well as it's along with its constructor, as it were. All right. So coming to my implementation here, I have my character class here, and the class definition on line 8. Then the private fields name, x position, y position, and of course the constructor right there. So of course you go ahead and copy this code and paste it inside of the evidence document as it will. Then moving on to item number 2, we have to implement the get x position and get y position methods, and by now you should know that these are getters. And for the most part, most IDEs in Java IDEs generate these automatically, so you just have to know which variables you're just picking. So in this case, we're doing get x position and get y position. Then we simply return the x and y position respectively. Of course, you'd copy the code and paste it inside of the evidence document. Moving on to item number 3, we are to do the set methods, that is set x position and set y position. Then we are to have those constraints inside of the set of the setters as it were. So for the new value that has been that's going to be set, it shouldn't exceed 10,000, right? So we have to limit it to 10,000. Then for the new value, it shouldn't be below 0. So basically, they're just saying that our value after setting it, it should be in the range between 0 to 10,000, right? So if you come to the implementation here, we have the set x position, right? So we are taking a new value as an argument. Remember, we are setting a new value to this x position value. So we are taking that value, then adding it to this x position right here. This is what this notation, the plus equal notation means, right? It simply means that x position is equal to x position plus value. So in the event that x position, the resulting x position is greater than 10,000, we're just going to set it to a maximum of 10,000, or we are just limiting it to 10,000. Then in the event that it is less than 0, we are simply going to revert it back to 0. So this is how you go about it. Then you also do the same thing for the y value, right? For the y set y position, it's exactly the same implementation that you're going to put in here. The only thing that you're going to change are the variable names. Then of course you go ahead and copy the code and paste it inside of the evidence document. Then moving on to item number 4, we have the move method that takes a string parameter up, down, left, or right. Then depending on the parameter passed, we should change the y position with these and the x position with these respectively. So we have to implement code for the move function right there. So coming to the implementation, you see that we have the move function, right? So we are basically using a switch statement to test all the 4 cases, then have a default case as it were. So we take the direction, then we convert it to lowercase in the event that maybe it was in uppercase, we just convert it to lowercase. Then in the case that it is up, we are going to set y position 10. Then in the event it is down, we set y position minus 10. Then left minus 10, right, it's plus 10 or just 10. Then in the default case, we're just outputting that there was an invalid direction. That was what that was applied. So not much going on there. So you copy the code and paste it inside of the evidence document. Then we are to declare a new instance of the character class, and we are going to call that object Jack. And we are going to set starting position to 50, and the starting y position to 50 as well, right? So for you to create an object of this particular in class, you have to come inside of the main method, is it? So remember, this is the character class, right? It's an independent class, sort of like a variable if you think about it. It's going to represent our character object, as it were. Uh, then here, now we now have the main class that is going to instantiate the Jack object on line 70 there. So we call the character class and we call the object Jack. Then we call the constructor from the character class and we pass it Jack as the name. Then the X position is 50 and the Y position is 50. Then for that, it's worth 2 marks. Then moving on to part C, we have the bike character that inherits from the character class. So we are to create the constructor as well as the move method inside of the bike character class, as it were. So let me scroll all the way down to my bike character class, which extends the character class, is it? So the way inheritance works in Java is to make use of the extends keyword. So the bike character extends the character class, and we are essentially going to have the constructor for the bike character is specified right here. Then it says that it should call its parent class constructor with appropriate values, is it? So in order for you to call the parent constructor or the constructor and the parent class, is it way, you need to make use of the super keyword, is it? So you are going to say super, then we have name, X position, and Y position, is it? So that's how you go about it. Then write program code to declare all right, so that's what we've just done there. Then item number 2, we need to implement the move method. Again, this is more or less the same as what we did in the character class, but this time around we are making increments or adjustments of 20, as it were. So we come to the move method, then we have to use the override notation so that our Java compiler knows that we are overriding the move method from the parent class. So again, the implementation is more or less the same, right? The only thing that's different this time around is that we are passing values of 20 and minus 20 respectively, depending on the direction that would have been supplied. Then of course you'd go ahead and copy the code and paste it inside of the evidence document. I want to come back up here. I noticed I'm using, okay, I thought I was using system.out because I had already imported system.out right there. So you don't have to go system.out, you just have to go out to print line. All right, so this is the bike character class, which extends the character class, right? Very simple and straightforward. Moving on to part D, we are to write program code to declare a new instance of the bike character class called color. So let's go ahead and look at that here. So there on line 17, we are calling the character class and creating an object called color. Then we call the constructor inside of the bike character class and pass those arguments as specified, color, 100, and 50. Then you copy the code and paste it inside of the evidence document. Then next up, we are to write program code to take as input which of the two characters the user would like to move, then take as input the direction the user would like the character to move. So let's actually do it step by step. So we create a new scanner object that's going to allow us to type in on the keyboard. Then we prompt the user to choose a character between Jack and color. Then we take that and store it inside of this chosen string right there. Essentially, we're just converting whatever the user types in to lowercase right there, is it? So we are using method chaining right there on line 79. So we call the next line function of the scanner object we created, then also call the to lowercase function on that scanner, on that user input, is it? Then we store it inside of this chosen string variable there. Then of course we are also going to take the direction, right? We tell the user which directions are valid. Then we also convert that to lowercase and store that inside of the direction variable there. Then next up, we need to determine, we need to call the appropriate method to move the character, is it? So we are going to make a decision using an if statement. So if chosen is equal to Jack, then we are going to move Jack with specified direction, then output Jack's new position, is it? And the way we are going to output his new position is we're using the getters that we did in create inside of the character class. Then in the case that the user chose color, then we are simply going to move color in the specified direction, and then we output color's new position, again using the getters and setters, but this time around it's from the, no, remember that this bike character class is inheriting from the character classes, so we are using the same getters and setters as it were. Then in the event that the user typed in invalid selections or invalid traces, we simply tell them that the kata is invalid. So this is the sample output. So you see that color's new position is x is equal to 100, y is equal to 200. So that's exactly what we've going on here. Color's new position is that much and that much is it. Then we have to test our program twice with the following inputs. So we have to check and write, then color and down. So let's go ahead and compile our program, compile and run our program rather. So let me just make sure that my console is clear. Then invoke the Java interpreter, Java compiler rather, not interpreter. So my file is question3 November 23v43.java. That's the name of my file. Then I hit enter. Then I want to, they said we should use back. Then it's moving, I think it was down, was it? Let's see. Yeah, it's right, actually, it's right. So we have, wait, what's happening? I'm now typing in the text editor instead of, so Jake is moving right. So Jake's new position is 60 and 50. Then let's run the program one more time. This time we'll choose color. Okay, what's happening here? Right, I chose the wrong class there. All right, so we have to choose color. Then we have to move it down, I think. Then the new position is that much, is it? So of course you'd go ahead and copy this code and paste it inside of, rather copy the output and paste it inside of the evidence document as it were. And that does it for this video. I'll see you in the next one.